Now, anytime you talk about noise, you always have someone who's going to say what? So you've had your chance, this is it, no more of that. Okay, let's be clear about what we're talking about. We're talking about these little cells that are deep inside your head that get worn down by noise. So what do we already know about noise? Well, we all know about the three little bones in the ear, and we learned that in grade school. We know that noise causes hearing loss. We know we have noisy workstations. We know that hearing protection is available, but more on that later. We can reduce the noise, but isn't that pretty expensive and hard to do? And we know that as we age, our hearing deteriorates. Now, just some of the stats. This was taken from the Ministry of Labor's materials that were online when they proposed the new noise regulation, $50 million. When looking at the number of claims, up from 3,600 in 2005 to 5,400 in 2009 from a 2011 report. I'm sure there's people here that have better and more recent. NIOSH has information on surveillance of over 1 million workers in the States, and they found that 18% of those audiograms were, and these are workers who are still working, were noise-induced hearing loss. And we've known since the 80s that between 80 or above 80 decibels, you have still a high risk, 10% of getting noise-induced hearing loss. The ministry, I believe, also referred to this paper about the lifetime risks of working in construction with regard to occupational diseases. And you see at the bottom there, 73.8% developing hearing loss. If that's not an epidemic, I don't know what is. 3/4 of retiring workers from construction getting occupational hearing loss. Now, there are also other effects, hypertension, not to mention the effect it has on productivity. I used to work in a foundry which is very noisy, and on Saturday they would have overtime, but the machines that produced the castings wouldn't be running, it would just be doing the other work. And you could tell the difference in the mood. People could talk with each other, they were happier, they were getting paid time and a half, that might have an effect. But one of the other effects, though, is vocal cord nodules on teachers. And this isn't due to the level of noise, it's the fact that they have to raise their voices to overcome the background noise. So there are lots of tools. If any area of occupational disease had a plethora of tools, it's definitely this one. I don't know if you've seen the Napo movies from Europe. They're really great. There's no words. I don't know if you watch Pingu, it's the same style of that. Work Safety BC has a great movie. It's a little long. The HSE in Britain has them. NIOSH has this really nice program where you can simulate hearing loss, and you can even add background noise, and you can dial in a person's age and exposure. It's a great thing for training sessions. Like I said, they teach this stuff in grade 4, so it's not we don't have to work to try to get it into the high schools. They should know it by then. There's also programs you can use to actually visualize the waveforms, so you can play them. And I like doing it because when you get up around 17,000 hertz, you can tell the difference in age, because the younger ones under 30 are going like this, and the older ones are looking around, what are you doing? And there's lots of apps for measuring noise, and also even to do audiometric testing on yourself. The OSHCO, I'm dating myself, also had put together a number of materials, but good luck in trying to find them. They do need updating, but they can be around. But what's the most common solution when dealing with noise concerns. It's the old thing that you shove in your ear. And the problem is, reminds you of the adage that if the only thing you have is a hammer, then every problem looks like a nail. In this case, the only thing you have is the earplug, then noise looks like just an earplug problem. But earplug problems have some issues. In the lab, we can fit them really well, and they can do a tremendous amount of protection, but in the real world, you don't get that protection. And not only that, even if you could wear it properly, but you didn't wear it all the time, let's say you took it out for a half an hour of your shift, you'd be losing phenomenal amounts, from 30 down to 13 in the most optimal. And that's if you're wearing it well, which most people don't. So whatever way you look at it, this is not the permanent solution. In fact, it's not even a very effective temporary one. So what is effective in preventing noise? Purchasing policy, new machines being less than 75 decibels, for instance. Vibration controls, quiet materials for conveyors, bins. Noiseless steel is an interesting thing that we experimented with when I worked in the foundry. Silencers, mufflers, specially designed for compressed air. Balancing machines, keeping them good preventive maintenance. Avoiding impacts in your process flow. Instead of dropping things from a bucket, sliding them into it, for instance. Enclosures, barriers, sound-absorbing materials. Keeping the noise away from the people. Now, the Buy Quiet, in the UK, I think they've had a law that actually requires this. And there was a recent article about some of the experience. And really, in order to do this well, you really have to have a sophisticated knowledge of noise and acoustics. And you purchasers especially really need to be critical about the information, because there's a lot of people that are trying to pull the wool over your eyes, manufacturers that have flawed data. So they really suggested that if you want a Buy Quiet program, you have to basically check on what people are telling you and confirm whether or not that's the case in your plant. So prevention opportunities. I want to use this continuum where we start at the source, follow it along the path, and then you have the worker who experiences the exposure, and then the target organ, and then the disease. So the best place to prevent, obviously, is at the source. Along the path can be good. Exposure at or control at the worker is supposed to be temporary. Now we can check on the effectiveness of this control using audiometric testing, and once you've got the disease, it's too late. There's nothing we can do except the hearing aids. Exposure, again, this is temporary when you're using hearing protection. This is a picture of an isolator, and of course, if you stop the noise in the first place, that's the best way. Motivations for doing it. The business case. Can we save money if we reduce the noise? Due diligence, compliance. We have a new regulation. I think we're trying to plug that part of motivation right now. A lot of people come to us asking about noise when they've had a WSIB claim. It seems to trigger them doing something about noise. Awareness, I'm not sure about that one. The internal responsibility system. Are we auditing our processes, and is this an item in our auditing system? But often it's personal experience. I'm sure every one of us knows somebody with a hearing loss. Now, the problem with motivations for chronic diseases is we're evolutionarily designed to respond to acute hazards, and we do that very well. But chronic hazards, it's the proverbial put the frog in the water and slowly turn up the heat and they won't leave, whereas you throw it in the hot water, it jumps out. So Daniel Kahneman, he wrote a book about thinking fast and slow, and he says we're actually wired not to be able to respond very well to chronic diseases. And the business case, too, is a problem. Robert Sass, who is the architect, the original architect of the 3 R's, he wrote that when it comes to industrial safety, the accidents, it's pretty, as long as you can show that the costs for eliminating it are more than the costs of the accident, direct and indirect, you can make the business case. But for occupational disease, because the workplace very seldom gets the full impact of the costs of the illnesses, there isn't a business case for preventing many occupational diseases. So we rely on legislation, and we have a new regulation about noise, even though we're not covering the 80 to 85 decibels. Sorry, Marnie, I had to plug that in. The regulation requires, it has a general duty clause specific to noise, and then requires protective measures, which include engineering controls. And while it doesn't require assessment, if you're going to do the assessment, it has to disregard the use of personal protective equipment, and workers should not be exposed to an occupational exposure limit, or OEL, of 85 decibels. And this is the wonderful formula that comes up with it. And so this obviously scares people. So we actually produced an online calculator where you can dial in the noise level, the time. You can do it, if you scroll further down, you can do it the other way too. And notice we have the concern about yellow is 80 to 85 decibels. But my son actually started work as an apprentice in maintenance, and he was concerned about the noise, and he said, well, how can I do this? And I've talked to him about the noise apps. He said, well, take the noise apps, measure the noise, dial it in there, and you'll know whether or not you have to put in your headphones, your earmuffs. Now about earmuffs, you're supposed to protect the workers from 85 without requiring the use of personal protective equipment, which seems to be backwards from what people are actually practicing. Now, there are times when you can't use engineering, and there are criteria there set out, but the idea behind the regulation is to prevent it through engineering. If you have to use personal protective equipment, you also need warning signs and adequate training and instruction on using them. But this room here, I'm sure you've been in some workplaces. How many workplaces do you think are in full compliance with Regulation 381/15? How many people think that 90% of workplaces are? Either you're shy or 75, 50, 25? Did I see 25? Yeah? 10%? More? 1%? None? Yeah. My guess, based on my own experience, is 1% or none. So OSHCO a few years ago had this program logic for evaluating the prevention system. As you can see, I'm dating myself again with OSHCO. It doesn't exist anymore, but I thought it was quite a neat, I'll just walk you through it very quickly. We have the inputs, all the prevention partners there, and they do stuff, and what they do is research, knowledge transfer, set standards and communicate information, etc., and financial incentives and social marketing for the WSIB. And then we have reactions to those activities and outputs, changing attitudes, increasing knowledge, developing systems, and reducing hazardous exposures. And hopefully they will affect the outcomes with fewer injuries, illnesses, diseases, or fatalities. Now, the leading indicators are the inputs, activities, and reaction. Obviously, the trailing indicators are the outcomes. Is Paul Bonfili here? He must have stepped out. He and I were on a dean panel on data measurement, so I want to show him that I was still using this stuff from 5 years ago. And then you have the system qualities and the effectiveness in the workplace. And so you can measure it either trailing or leading. So how do you measure activities? Well, you can look at how much money was put to the research, the number of knowledge transfers, pieces of information, website hits, people in training sessions. You can count the number of WSIB commercials, the amount of incentives they've put out. You can even count Ministry of Labor inspections, orders, and blitzes. And here's the money, the training, the social marketing, and the OEL, of course. But which one of these is most effective? Well, in Sweden, they did a blitz on workplace noise, and they did it a number of different ways. This study was published. So they inspected 1,700 workplaces in 2 days to evaluate the effectiveness of their noise programs. And they sent out questionnaires afterwards to find out what they did. They also sent the same questionnaire to match controls who were not expected, but were contacted with information and things like that. And on average, the inspected workplaces implemented 2.5 types of action compared to only 0.8 for those who were not inspected. And 83% of the inspected workplaces said the inspection was the reason for them doing things. So the study really shows that inspection campaign is a highly successful way of getting organizations to do something about noise. So enforcement seems to be the one that really counts here. Now, what about the reactions? How would we measure those? Well, for attitudes and values, you can do surveys. You can test workers' knowledge, see if they can actually put the hearing in properly. We did this in the foundry where we took them off the floor with their hearing protection in and did a hearing test, and then asked them to take it out and do it again so we could actually measure how well they could wear them. You can audit programs, but what about just measuring the noise and doing audiometric testing? So we have a lot of things, that the surveys, the tests, the audits, but measure seems to be the most direct way of telling whether or not the noise is being reduced. So between measuring and enforcing, I think you can get a lot done. But who can measure? I've got a few of these machines. But really, these days, anyone can measure. And NIOSH has done some evaluation of some of these apps. Some of them are bad, and some of them are very good. This one works very good. And it not only measures the noise, it gives you the octave band frequencies. It can time weight the average. You can download it. There's all kinds of things you can do with it. You can also measure reverberation with apps. And when we're thinking of teachers with vocal cord nodules, there's a standard that's freely available for schools on reverberation. You can even get an app to measure vibration. I was tempted to use it this morning in the GO train, but you have to sit on it, and I thought that might be a little awkward. And there's online audiometric tests where you actually calibrate your sound system for your computer, and then you get your hearing level. So I was thinking, what about crowdsourcing decibel? Pick a date. For instance, International Noise Awareness Day is on April 26th. In 1917, it's the last Wednesday in April. If you make it known, pass it around through social media, and coordinate data collection. Email your results. You take your app into your workplace, measure and email it to your supervisor, your health and safety rep, your union, or OCAO. How about the Ministry of Labor? And create a form that gets a bit of information about the workplace and asks whether or not there's a sign up, the type of hearing protection, whether the engineering controls have been considered, and actually provide a list of all the types that could be considered, and any audiometric, you know. So lots to do on noise.
Great.
Thank you.